All right, this video is to introduce you to our use of the pH scale in Math 4, and it involves a logarithmic equation. So, Leslie Sorensen invented the pH scale in the early, I want to say 1900s, and chemists measure acidity of a solution by giving the solution a pH rating, which is probably what you're used to. The rating is defined by, or the scale that he invented, pH is equal to the negative common logarithm of what's called the hydrogen ion concentration. So that's what the H plus is here. This is the hydrogen ion concentration. So let's label that. This is the hydrogen ion concentration. And this is measured in moles per liter. Concentration. There we go. I think that's spelled correctly. We'll hope it is. And so it's measured in moles per liter. If you want to abbreviate that, it's just going to be moles per liter. All right. And so let's take a look at a sample problem that we could possibly see. So example number 1, the average pH of acidic rain in North Carolina is 4.4. This is accurate. Find the hydrogen ion concentration. All right, if they're giving us a pH value, that's going to get put into the left-hand side of the equation where we see pH on that previous slide. Then it's be equal to the negative logarithm. I should say common logarithm of the hydrogen ion concentration, which is what they're asking us to find. They're asking us to find that hydrogen ion concentration. Now, the only thing we have to deal with in this equation before converting it to exponential form is the negative right here. We've got to get rid of that negative. So what I'm going to do is I'm going to come in and I'm going to multiply both sides by a -1, which will clear the negative away from the logarithm. And so all that's going to do is make this 4.4 negative, and it'll still be equal to the common logarithm. Now the logarithm's positive, which is what we want, of the hydrogen ion concentration H plus. And now we'll go ahead and rewrite it in exponential form. So since it's the common logarithm, it means we have a base of 10. We're going to raise that to the -4.4 because remember the logarithm is equal to the exponent. And then this will be equal to the argument of the logarithm, which was our hydrogen ion concentration. And so now all we need to do is go ahead and evaluate it in our calculator. So we're going to take our calculator and we want to figure out what 10 raised to the -4.4 power is approximately. And so it says 3.98. But if you notice on the far end, we have an E -5. And that's saying the same thing as times 10 raised to the -5th power. It's basically the same thing as scientific notation. And then we'll say that is in moles per liter. And that would be our answer to this problem, about 3.98 rather, times 10 to the -5th moles per liter.